Hi everybody. In this lesson we want to talk about graphing quadratic equations that are given in general form, something that looks like this. Okay? And you should remember that if we have a quadratic equation that's written in this form, that we call the vertex form, then it's very easy to graph. And you can look at this, and because it's in this form you can say, oh, I know that it's going to shift horizontally h units, and it's going to shift vertically k units. So my vertex is going to be simply, I look at these numbers right here, it's going to be h and k for the vertex, and then this value of a tells you if the parabola is going to open up or down. Depending upon if a is a positive number, it'll go up, and if a is a negative number, it'll go down. And it'll also tell you how wide it opens up. It'll be a fat looking parabola if that a value is a fraction, all right? In other words, it's between -1 and 1, like a half or a third or a fourth or negative a half. And then if the value of a is a number like 2 or 3 or 4, which another way of saying that is the absolute value of a is greater than 1, then it's going to make it look skinnier. Okay? So if I can write a parabola in this form right here, then it makes it easy to graph. But most of our quadratic equations are given in this form, and so the question is, how might I write an equation or transform this equation to look like this? Now you might relate this back to what we learned about lines. You remember that the general form of a line is ax plus by equals c, and if I write that in the form y equals mx plus b, in other words, if I just solve this equation for y, then I can look at the coefficient of x and figure out what the slope is, and I know this b is the y-intercept. And then if it's in this form, it's really super easy to graph. Well, so again, the question is, how are we going to rewrite a quadratic equation like this that's in general form, that's in this much easier to graph vertex form? And the answer is by something we've learned before, completing the square. Now when we complete the square to rewrite a quadratic equation for the purpose of graphing it, there's a couple differences that we'll want to note here. Okay? So suppose I want to graph x squared plus 6x plus 8, and I want to do that by writing it in this easy to graph vertex form. Well, you remember when I solved quadratic equations by completing the square, I had x squared plus 6x plus 8 equals 0. This would be an equation, and there was always an equal to 0. And what we did was I always completed the square on just these two terms. So I got x squared plus 6x equals negative 8. So I isolated those two terms on one side of the equation, and then I took half of this middle term, half of the 6x, half of 6 is 3, and then I squared it. And I added 9 to both sides, and then this was a perfect square. Remember, too, the leading coefficient has to be 1 in order to complete the square. So this is a perfect x plus 3 times x plus 3 equals 1, and then you'd have x plus 3 squared equals 1. Okay? Well, we're going to do something similar to that. But here I want to keep everything on one side. So what I'm going to do is, instead of taking the 8 on the other side, what I'll do is I'll take the x squared plus 6x, and I'm going to group it by itself and leave a little space to complete the square, and the 8 I'm just going to push off over here a little further on the right. Now I still need to add 9 to complete the square. Now instead of adding 9 to both sides, what I'm going to do is I'm going to add 9 here, and then I'll just subtract 9 out here. So 9 minus 9 is 0, and you should see that what I have in blue is still my original equation, right? X squared plus 6x plus 8, and the 9 minus 9, they cancel each other out. So this, I can now write, this is a perfect square. This is x plus 3 squared, and 8 minus 9 is negative 1. Okay, so I know that if I want to graph this parabola, this quadratic equation, I know it's going to shift my normal x squared graph 3 to the left, so my vertex is going to be negative 3, and it's going to move down 1. So my vertex is 3 to the left and down 1, And then I know it's going to open up. There's an understood 1 out here, so it's going to open up just like my normal x squared, where I go over 1, up 1, and over 2, up 4. I think that's right here. Okay, I could go over 3 and up 9. 3 squared is 9. Anyway, I'll just put some of those in there, just a few points, and just connect the dots. All I want is a sketch of this. If I want it really accurate, I'll graph it on my graphing calculator, right, or some other software. Okay. Well, notice that on every parabola is symmetric about the line that goes through the vertex. So in this case, my axis of symmetry is going to be at x equals -3. In other words, it's just where the x value of your vertex is. You can see that my x-intercepts here, you can pull them off the graph, -2 and -4 it looks like, or you would go ahead and just solve this, right? The x-intercepts are where y equals 0, so you want to solve where your function value is equal to 0. And notice that was really the equation I was solving up here, right? So if I were to keep working this problem, notice I'd get x plus 3 is plus or minus 1. And that would mean that x is a -3 plus or minus 1. Now, this is sort of a nice way to think about that. Because, see, here's your x equals 3. And if I go plus 1, there's one x-intercept. And minus 1, there's the other x-intercept. Or, of course, this one was easy enough. You could have just factored it, right? 0 is x plus 2 times x plus 4. And there you'd get that x is -2 or -4. The y-intercept is where x is equal to 0. So the y-intercept is f of 0. And if I plug in 0, I'm going to get 0 squared plus 6 times 0. I love plugging zeros in these, don't you guys? And then just plus 8. So my y-intercept's 8. So notice if I were to go over 3 and up 9, that is going to put me right up here at 8, which is where the y-intercept should be. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to cross right there. I could extend that up if I wanted. And all right. Likewise, there's going to be because of the symmetry, there will be a point over here as well at this point. Okay, and that gives me a nice sketch of the graph. Now let's go on and do one more example. And the purpose of this example is that the middle term isn't a nice number, so we have to deal with fractions a little bit. But again, the procedure is I want to group just the x terms together, so put x squared plus 5x in parentheses over here, and leave a little room to add something in to complete the square, and just push the 6 over here. So right now, all I did was just sort of rearrange the terms a little bit to make room to complete the square. Now I'm going to add in here half the middle term squared. Now where students make a mistake is they try and do too much in their heads, and it's just so much easier to just take half of 5 and square it. And you can just write that down just like I did right there. Okay? You don't have to, figure it out and do it on your calculator. Just write down exactly that. And if I add 5 halves squared here, then I have to come over here and subtract 5 halves squared. Okay? Then this right here, by completing the square, this is going to be a perfect square. And not only that, but you know what it's going to be. It's going to have to be x here. You're going to have to square x to get x squared. And you know what this one is, right? It has to be 5 halves, so that when you square the 5 halves, you get the 5 halves squared right here. And now over here, I'm going to have to get a common denominator. So I'm going to write this as 6 over 1. I'll leave a little space. Minus 25 fourths. So let's take, multiply this one by 4 over 4. And so I'm going to get my f of x. I've rewritten it now. This is x plus 5 halves, quantity squared, and 24 minus 25 is a -1/4. So I know my vertex, this is my nice vertex form. This form tells me I'm going to shift my normal x squared graph 5 halves units, that's 2.5 units to the left. So that'll be -5 halves, and then down 1/4. All right, so if I want to graph that, I'll go over here 2.5, that'd be right here, and then down 1/4 is about right there. Okay, I know the axis of symmetry automatically is x equals -5/2. To find the x-intercepts, again, I want to find where y is equal to 0. So I'll just set my function value equal to 0. That'll give me x squared plus 5x plus 6. And then I can solve this one by factoring. That would be x plus 2 and x plus 3. So I get that my x-intercepts are x equals -2 and -3. So notice that's going to be this point right here and this point right here. And remember, my vertex was right here. I don't really need that other little dot there. Let's just erase that so I don't confuse myself when I go to draw that. All right, but that was the x-coordinate of the vertex. Okay, so what's going to come down is going to go back up here. Okay, and for the y-intercept here, I'll have f of 0. I want to plug in 0 to find the y-intercept. So if you plug in 0, you're just going to get, 0 squared, 0, everything with an x cancels out, and you just get 6. So that would be this point over here, 0, 1, 2, 3, 4, 5, 6. So that gives me something to aim for, and you can see this is working out. I'll just get that look like that. There'd be a corresponding point over here. That's like 2.5 on the other side. That'd put you right here, so there must be a point up there as well. And there we have it.